This is Iwara of the supercontinent cycle. Well, that's what I'm calling it. It uses a Pitjantjatjara word used to describe tracks of creatures that move across the sand. But in this sense, I'm referring to the Chukaricha, the ancestral beings, as they move across the land and created it, they left tracks. So I'm using that word to describe the deep space and time tracks of the continents as they move through. They assemble and they disperse, they assemble, they disperse, and in doing so they create, destroy, transform the landscape that we witness today, and particularly the uniqueness of Uluru. So in that sense, I'm paying homage to Chukapa in the way that it gets it intuitively so right in the description of how this landscape came together with those massive continents coming together. The supercontinent cycle for me tells a much grander story and ties in these different elements, these seemingly disparate events into a recognisable cycle, and that they are intimately related over that vast time. Tells a story of deep time, space, but also deep power, deep earth power as well. So supercontinent cycle, when you look at it, resembles uncannily the stories of Chukapa, especially when you depict it within the sand like this. You recognise that could possibly be a Chukapa story, and wow, they seem to have got it so right yet again. I'll begin the story. We go back some 2 billion years when Australia was being formed, and in fact the formation of Australia is the parallel story of the formation of Uluru, so they run parallel to each other there. And the story begins with the Australian Kratons coming together. You have the Pilbara, the Yingan province, the Gawler province coming in, and they represent the core part of Australia, the first elements that are coming through. And we have other participants that makes up this first supercontinent, and this is Nuna, and that's about 1.8 to 1.5 billion years. About 300 million years of Earth history represents the first supercontinent that we're going to talk about here. We have other participants coming in. We have India coming in at the very least. We have North America and we have Europe. So fairly sizable supercontinent at that stage, lasting 300 million years. And during this time, Western Australia and also South Australia formed, but also the North Australian Kraton, or the Northern Territory, accreted itself into existence from north to south. So the main elements of Australia, at least 2/3 of Australia, was formed in that supercontinent of Nuna 1.8 to 1.5 million years ago. Anyway, as we head down the arrow of time, Nuna loosened up and broke off into bits and pieces, and then it started to reform into the next supercontinent, and that's Rodinia, about 1.1 to about 900 million years ago, 1.1 billion to 900 million years ago. So that was a fairly sizable one, and all the bits and pieces started coming back in to form the next supercontinent, Rodinia there. So they all come in together, but we have other participants here. We have South America, we have Africa coming into quite a sizable, much bigger than what we had beforehand. Now, important steps that goes into the formation of Uluru are starting to occur at this point. So about 1.35 billion years ago, we had the Mount West orogeny that essentially brought the Kratonic parts of Australia. We had North Australian Kraton come in, the West Australian Kraton, the South Australian. They all came in together and essentially created Central Australia, and that is essentially the tectonic setting of where Uluru will later form there. But what was also important, a later orogeny, the Musgrave orogeny, underneath that was placed the basement material of Uluru that will later become the sedimentary materials. material of Uluru. So this particular supercontinent was particularly important, setting the scene for the formation of Uluru, and that's Rodinia. And that occurred about 1 billion years ago. Now, Rodinia, about 900 million years ago, starts to break up. We have the elements of what will later become Gondwana heading off down in the southern hemisphere. We have the other parts heading up the northern hemisphere that we know of, and that's Eurasia and North America. Now, in that split here, we have the Pacific Ocean, and when that split up, Australia was essentially stretched and thinned and down warped in central Australia, creating the Centralian super basin, which broke up into little bits and pieces. Part of that was the Amadeus Basin, and that's very important part of the formation of Uluru. Anyway, that occurred about 830 million years ago. So elements head off, and of Gondwana heading down, we have Eurasia, North America heading off, and then about 580 million years ago, all these elements started to suture together and create Gondwana, effectively. We have West Gondwana, East Gondwana, and over about 50 million years they all came together and created quite a sizable continent. So lots of geologists debate whether it was a supercontinent in its own right. For me, it constituted many, quite a large landmass there, where we've got South America, Africa, Saudi Arabia, Madagascar, India, Australia, and the Antarctica, Zealandia, so many elements there. So it was fairly big, definitely. And then during this period of time, we have the Petermann orogeny, which threw up mountains quite aggressively in central Australia and created huge amounts of sedimentary material that flowed down into the Amadeus Basin, and that would become the Mutitjula Arkos of Uluru and the Mount Currie conglomerate of Karajuta. So that was an important initial stage of the arrangement of Uluru. Anyway, we continue on. The next supercontinent comes into play now. We've got Pangaea, and they come and converge. Pangaea was enormous, covering from pole to pole. It's getting really big now. Gondwana, Laurasia, or North America and Eurasia coming together. And during this early stage here, we have the of the assembly of Pangaea, we have the Alice Springs orogeny, and that began about 450 million years ago, and that's when these continents started to come together and create a lot of shortening or compression within Australia. And that lasted about 150 million years to about 300 million years. That's the Alice Springs orogeny. All the sedimentary material was tilted up vertically. We can still see that tilt today in Uluru and Karajuta. And it was a multi-phased orogeny. So there was about 4 distinct pushes within the Alice Springs orogeny that created not just the tilt of Uluru, but the McDonnell Ranges. And about 300 million years ago, we could say definitely Pangaea had formed and lasted about 140 million years. This is when the dawn of dinosaurs pretty much started to occur. There's a mass extinction about 250 million years ago. So Pangaea was a really interesting continent. It was the first continent that was actually green, first supercontinent that was green. That's the emergence of plants that came out. And about 180 million years ago, it all started breaking up there. We have South America heading off, Africa starting to head off, creating the Atlantic Ocean there. We have Australia, the core part of Australia, and during this stage, as we go back a bit, we have Gondwana, and it was during Gondwana that the rest of Australia was formed. We have essentially east of the Tasman line, most or southwest of Queensland, or southeast rather of Queensland, New South Wales, Victoria, was formed during this Gondwana period leading into Pangaea. So by now, Australia had pretty much formed in its entirety there. Australia starts to head off. The Antarctica starts to split off there. We also have India coming apart there. Again, we've got South America, Africa, India, Australia, Antarctica, and of course we have North America and Europe heading off. And essentially this is where we are at the moment, about here, the present time. Now the interesting thing is that India's come over and started to crash into Eurasia, and this is the Himalayas that we have here, and that started to happen about 47 million years ago. So India's just skirted across here to crash into Eurasia. Africa will also come in and crash into Eurasia. The Mediterranean Sea will become the Mediterranean mountains there, and then that's not it. Australia will continue and then also crash into Eurasia. And so we've got India, Africa, Australia, all starting to form the next elements, or the next part of the future supercontinent there. It all starts happening about 70 million years ago. It's already started to happen with India, Africa in about 20 million years, and Australia in about 70 million years, and then of course North America will start to move across the northern hemisphere. So the idea is that one of the many models is that the next supercontinent will form roughly over the North Pole there, and create the next supercontinent, the future one, the working title of Amasia. So there you have it. You have an outline, a sand drawing of the supercontinent cycle in the simplest form there, just beginning back here, lunar, 1.8 to 1.5 billion years ago, and then it loosens up again, reconvenes, reassembles to form Rodinia 1.1 billion years to 900 million years ago. Important, sets the tectonics, or makes the tectonic setting for the formation of Uluru, creates the Amadeus Basin. That's important. It breaks up and then starts to form initially as Gondwana. During that assembly of Gondwana, the Petermann orogeny was thrown up or creating the Petermann ranges and the sedimentary material of Kalajuta. And then going into the last supercontinent, we have Pangaea. And Pangaea, that was essentially when the Alice Springs orogeny occurred, that created the tilt of Uluru that we see today, but everything else around here in Central Australia. And then that definitely existed about 320 to about 180 million years ago. So it's a short, sweet supercontinent, very, very big, and then breaking up to the 7 continents that we easily recognise today.